Hello all, welcome to course of Power System Planning and Reliability. And in this lecture, we are starting a discussion related with generation planning. And this is very first lecture related with this topic. So we are going to focus a very fundamental understanding related with generation planning. So let us see what are the objectives of this lecture. So in this lecture, you should understand what is the structure of power system planning. Then we are going to review some important questions which must be answered when you are doing generation planning. Then we have to formulate optimization problem for a generation expansion scheme. So we are going to see what are the characteristics of that optimization problem. And then we are going to understand various fundamental economic assessment methods. So please clear one thing in your mind. Our focus of this lecture is not at all detailed mathematical analysis, but we are going to understand concepts related with these topics. Now, expected outcomes at the end of this lecture, you must be cleared with the concept of generation planning and its importance. Then, what's the nature of optimization problem which are we are going to form for generation planning, and then a theoretical knowledge related with various fundamental economic assessment methods and what are their characteristics. So, before starting discussing generation planning, you must have learned some subjects related with power system in your earlier curriculums of undergraduate or as well as postgraduate. So those subjects might be like power system generation, power system uh, operation and control. So in that, somewhere you must have gone through various government entities, various government departments which form these policies related with generation, transmission, distribution, your energy policies. So those departments like Central Electricity Authority, Central Electricity Regulatory Commission. So my request to you is just again go through what are the functions of these entities. Then you must be aware of what is a very fundamental thing related with power system operation. What are the different algorithms? What are the needs of uh, stable power system operations? And then some mathematics related with optimization problem, which you must have learned in some of the subjects like numerical methods, computer programming, computer applications in power system likewise. Now let's understand what is structure of power system planning. So power system planning always starts uh, at that entity level where you are going to plan these energy policies, and then that goes to overall power system planning via energy planning. So first focus is always on you have to plan the energy. Now energy planning means there are n number of primary sources or fuels which we are using for power system or power generation. So those fuels like a coal or a nuclear energy or a hydro. So you have to check always before taking any decision related with power system planning that what is the availability of these resources. So we are continuously monitoring the availability of these resources, and then accordingly we are planning our further activities in power system like generation expansion and transmission networks and all. The very good example I would like to quote, if you observe our generation planning since last 5 or 6 years in country, you can observe there are a number of solar power plants being added, and there is some restriction on addition of thermal power plants. So those kind of decisions are taken depending upon the availability of coal, what's going to be the future of these fuels, and all these things are over there. So after energy planning, ultimately you are again going to your overall power system planning. Now in power system planning, there are three important points. One is your power system load forecast. So please understand, our power system is called as a load following system. So whatever may be the demand of the load, that we have to fulfill, and that's why we are calling that as a stable operation, means supply is equal to demand. That is very fundamental thing. Now when you are starting power system planning, the first thing you have to do is your load forecast. Once you do load forecasting, you can take the decisions related with generation expansion, which power plants you can add into the system. Like your decision may be to add a single coal power plant, or a hydro power plant, or a nuclear power plant, or depending upon the availability of wind speed, you can add some wind power plant or solar power plant. So depends. Now again, once you take the decision related with generation, there must be some system to evacuate that power. So you have to accordingly expand your transmission network also. And in here in this diagram you can observe there is a reverse arrow also. Why? Because in this it's always a closed loop system. So whatever is happening at the field, you must get a feedback also. That's why here inside power system planning, you can observe there is always a feedback in between your load forecast, generation planning, and electrical network planning. So let us go ahead. Yeah. Now, so whenever you are doing generation planning, there are very fundamental questions which you have to ask to your system. And as you are aware, a generation planning requires focus on three dimensions. So, generation planning, one is that must be technically foolproof. So, what's the requirement? It's a supply demand balance. Another thing is, uh, if you only focus on technical side, you may slip your overall planning as far as economics is concerned. So another thing you have to focus on economic generation and load dispatch. So you must have gone through some concepts like economic load dispatch, uh, or economic generation in your subject like power system operation and control. Some optimization methods like Lagrange's multiplier, uh, or Newton-Raphson method. So these kind of methods may be applied for calculation of economic generation or economic load dispatch, and then you can take the decisions related with economics. The third important thing is reliability, which is in a very simple manner. We want always a 24 into 7 electricity supply. So if you want electricity supply 24 into 7, there must be a generation operation 24 into 7. Now this reliability can be again categorized reliability during operation, reliability during project, whichever you start and whichever goes on. So when I'm starting my project, whether this project is reliable, whether this will finish or not. So that is again another kind of reliability you can think of. Now those questions which we want to ask to overall generation planning may be related with major four types. So the first question is, at what time you can add the generation unit. So what's the time of expansion? Another thing is where I should add. So that you have to decide depending upon your, when if you want to add thermal power plant, you should always think of there must be availability of nearby rail line to transfer the coal, or there must be some availability of nearby mine also. So that's the consideration, and some of these points you must have gone through your subject of power generation also, power generation technology. What's the criteria to put any hydro power plant, or what's the criteria to put any thermal power plant, like that. Then you have to again decide type of generation. Now these two things are like sequence may be changed, because some of the times coal is available, so you are putting power plant, and then some of the times you are deciding first what may be the fuel, and then you check the availability of that fuel, and then you decide the location. So depending upon, you are going to fix location first, or you are going to fix the fuel first, that may vary. And then again, what's going to be the capacity? So in thermal power plant in India, you are aware of there are technologies like 500 megawatt, 660 megawatt, 800 megawatt. So which is your capacity you want to expand. So that decision is also to be taken. Now at international level, there are various models of optimization uh, these all optimizing all three dimensions are available. So some of the names, short forms I have mentioned over here, because we are going to see these models in detail throughout our course in further lectures. So some of the short forms, in short forms I have mentioned those models like WASP. This is a typical model given by America. One is IAEA, another is WICPAN, another is MNI, which is given by Japan. So some of these optimization models which will help you for generation planning are over there. Now what is that optimization model? Is nothing but you are having a standard algorithm. With the help of computers, you are going to solve that optimization problem. So the reason behind coming up these tools or these optimization problem solutions is nothing, because of your research in computer as well as research in mathematics. So let us go ahead and let's see what's the optimum generation expansion. So there are some criterias, there are some six criterias for which you have to consider a optimum generation expansion. Now whenever you want to expand any generation plant, the first thing you have to consider is whether this project is feasible or not. So feasibility of the project. Another is cost of primary energy resources and fuel. So you have to always consider what's going to be my cost for primary energy resources as well as fuel. The next thing is what's the cost of investment flow and annual operation of the scheme. So that is another thing. What's the reliability indices for electricity supply? So there are two standards, IEEE 493, IEEE 1366. So they always give you some different reliability standards like SAIFI, SAIDI, KAIDI. For generation system you are having LOLP, LOLE, like those indices are over there. Those you have to consider. Another thing is you have to understand the economic sensitivity of the scheme, whether after completion of this project is it going to impact my cost of fuel or cost of electricity generation. That you have to check. And last but not the least point is effect of delaying key projects. And this is typical in India. Sometimes you plan your project for 4 or 5 years and it gets delayed for 7 8 years, because in country like India we face a lot of uncertainty challenges. And what's going to be the impact of delaying projects on your overall planning, that you have to consider. And that's why it's a very complex problem. But uh, generation optimization problem you can define by three combining three things. One is this problem is multidimensional. This problem is multidimensional because there are uh, numerous variables are there, because you have to take n number of decisions related with n number of variables. N number of types of generations are available. Once you decide coal, that's a thermal power plant, then you have to think of availability of coal, then transportation, then storage, then what's going to be the coal mine. Then if I store the coal and there is some there is some damage to that fuel, uh, what's going to be the my plan B. So in n number of ways, very complex problem, very difficult to discuss in a single lecture. So that's a multi-dimensional problem is over there. Another thing is uh, whatever constraints I discuss right now, they are not linear to the decision variables. So if I take a decision, I cannot write down any linear equation related to that. That's why it's a non-linear problem. And in mathematics you can understand when your problem becomes non-linear, that's a very complex problem. Now third thing is, and again adding complexity to it, it's a stochastic. Now what is stochastic? Stochastic, it's a related with randomness. So there are uncertainties. Uncertainties are there in data requirement, like as we have discussed structure of power system planning, we require a load forecast data. So what's going to be the load? Very uncertain, always fluctuating. Like discount rates, they are changing as per economic situation of the country, overall economic flow um, in the country or in the system. Then what's going to be your fuel and equipment cost? So those are stochastic things. So that's why please understand and please fix in your mind, this generation optimization problem is a multidimensional problem, which is a non-linear problem. It's a stochastic problem. And last point of this lecture, what's going to be the fundamental economic analysis. So fundamental economic analysis is divided typically into three major types. So first type is a static assessment, very simple, no complexity, very first type of fundamental economic analysis, and it is simple because the time value of money is not considered. Now what is time value of money? In a very simple manner it is explained that what's the value of amount rupees 100 today will not be the same amount tomorrow. It will be somewhat less, like today's 100 rupees, tomorrow it will be 90, then 80, and like that. So that time value of capital is not considered in this assessment. So it is very simple and direct, where change in gains and costs throughout the projects are not considered. But the another thing is it cannot be applied to very complex projects. So it is applied to only simple projects where you are going to check the feasibility at very initial phase. So that is called as a static assessment. When we want more accuracy, we are shifting to dynamic assessment, where the time effect of capital is considered. So time value of money is considered, and it is again divided into four types, which we are going to see in our further lectures of generation planning. That is net current value, internal profit rate, current value cost, and equal annual cost. So these four methods are dedicated to a dynamic assessment. And our last fundamental economic analysis type is stochastic assessment method, where you are going to consider uncertainties and inaccuracies. uh, and the types are profit and loss balance, sensitivity analysis, and probability analysis. It is also called as a risk analysis. So what we covered in this lecture is, we started discussing the structure of power system planning. Then we tried to understand what's the nature of generation optimization problem, what dimensions you must consider whenever you are doing any generation expansion, and at last we have understood fundamental economic analysis. So in next part we will start discussing this fundamental economic analysis method one by one in detail. Thank you.